Okay, so I'm going to talk today about the latest generation of skipper products. This we call generally the multi range, and I will be talking through the technologies, the advantages and disadvantages of the different types of speed log, not just the skipper speed logs, but all of the ones on the market. How to design it into the vessel, the installation and setup, how you install it into the vessel and how you run it through a sea test, the service and support. And I will do that on
We lost your voice, Paul.
Voice.
Sorry, I somehow clicked on the wrong thing there. So we'll start with the speed log technology. I will be going quite quickly through the different systems, as I will try and keep to the 40-minute time limits that I've set for this. So we'll start with the speed log technologies. Now, there's a number of technologies you can have on a speed log. If you go back to the very olden days, they used to tie knots in a rope and they'd throw the rope over the back of the boat. And as the ship sailed away from the rope, they would count the knots going past. That's where the terminology knots came from originally. Obviously, we don't use that nowadays. The next version they had was an impeller being towed behind a vessel, a little propeller that was put in the water, and as it twisted around, it gave you a value of speed. Again, a little bit impractical. That impeller they eventually moved onto the vessel. It was mounted in the bottom, and you see this on small boats still today, a little propeller that goes round and round. Has a few problems in that it gets stuck with time. Things grow onto it and it goes slower and slower and becomes unreliable. Then you get to the more industrial type of sensors. You have the electromagnetic sensor, which is generating small currents. It basically puts a magnetic field into the water, and then using this horrible law you had at school, which is called the left-hand law, you put field into the water, you have a motion of the sensor, and then it generates a current. We also have the Doppler system. The Doppler system measures the particles in the water, or the bottom, which is like one big particle, as it moves forwards towards the sensor or away from the sensor. So this is like the ambulance syndrome. As you hear an ambulance go past, you hear the frequency change. As it moves towards you, the frequency goes up, and as it moves away, the frequency moves down. So this is the same principle that we use on the Doppler, but we measure on the particles in the water, or we measure on the seabed. Then in later years, you have the GPS system. Of course, not just GPS, but GLONASS and all the other systems as well. But this is basically a navigation system that if you take your position for 1 or 2 at a time apart, you can work out the speed you're going. And if you have 2 antennas, you can also work out the direction that you're going. So a GPS speed log normally needs to have a direction and the speed, which speed you get from the normal GPS, the direction you get from a dual head system. Then you have the correlation system, which takes a kind of snapshot, a photograph of the bottom or the particles in the water. And after a little time, it takes another picture, and then it compares those 2 pictures and works out how far the vessel has moved in between each. Quite a complicated system. And then finally, coming in recently, are radar systems, where the radar is also using Doppler, looking at the sea surface, and then trying to work out the movement using that Doppler. So some of the issues we have here through speed through water only systems, then you have the rope and you have the impeller. Anything that is moving in the water is a bit of an issue because it will grow. On the right here, you see a picture of a static impeller system that has grown quite a lot. I don't think you'd get very much speed out of that system. The electromagnetic systems, they have a little bit of issues with growth as well, in that they have 5 pins on the bottom if it's a 2-axis system. And those, as they grow, they will get more resistivity, and that will make the speed go down slightly. So they have to be cleaned at regular intervals. They also measure very close to the ship itself. So the ship will be dragging some water with it, and that will make the speed slightly lower than you would expect, the actual speed through water. So you have to calibrate it to measure the water that isn't being dragged by the boat. The radar has issues as well. It measures at the surface. It does penetrate slightly into the water, but it means it is measuring at the surface. The wind effects, the wave effects will have an effect on it. It's also quite an expensive system in that it requires a radar. If it's to be a standalone system, it has its own radar, but there are some versions available that use the standard radar, but they cannot be approved as speed logs. Then you have the SOG only system, speed over ground only, the GPS system. This has and GPS is a reliable system. It works very well. It has a few issues. You have an antenna which is on the top of the mast, which will be wobbling backwards and forwards in waves. That can give you a little bit of instability in speed, short-term effect. You can also get blind zones if you go into fjord areas, for example, or into very northern or southern areas, then there's slightly worse coverage of satellites. But generally, it's quite a good system. Then you have the combined systems, the speed over ground and speed through water systems. The Doppler has a few issues, but not very many. It measures distance at a distance from the hull, so it doesn't have the same issue as the EML, where it is measuring drag of the vessel. If you measure further out, you get less drag from the vessel, although this drag from the vessel can be quite considerable, and it can go quite deep as well. So if, for example, you have a super tanker going in shallow water, you will have an effect right down to the bottom of the water being dragged with the ship. And as a speed through water system is trying to measure the influence of the water on the ship, the question is, what is correct? Is it correct that you're measuring a long way away from the vessel like a radar, or are you actually interested in what is happening to the vessel itself? That opens a whole new debate, which is coming into the market a bit now with efficiency systems. What is the real value? Then finally, the correlation. It's quite a good system. It measures vertically as opposed to on a slant like Doppler. It is quite a complicated system. And usually it's 2 systems. It's not, you can't do speed over ground and speed through water on one system or measurement. Looking at the speed logs that Skipper has, we have the Skipper EML system. We are working on a new graphic version of the EML and the DL1 at the moment, but currently it is the dot matrix system. The advantages of it is it's a very small sensor. It's 60 millimeter diameter, which means it has a smaller valve, more cost effective. It can be 1 or 2 axis, and it's a smart sensor, which means that there's no analog signals going up the cables, which means you can cut the cable, you can extend the cable. As long as you get enough power to the sensor, then you can have as long cable as you want, pretty much. It also includes a temperature sensor. The DL1 is also in the same format, so it goes in the 60 millimeters. This is just a 1-axis system. It has 2 beams, one forward, one aft, both measuring speed, and the average of that is what you end up with. It's low cost, costs about the same as the EML, and again, it's a smart sensor, and it has temperature sensor on it as well. Then we go to the slightly more advanced systems. The DL2 Doppler system is a 100 millimeter sensor. It's still quite small for what it is. It goes in the larger C valve or tanks. And this one measures both speed through water and speed over ground as its primary measurements, but it also measures depth, temperature, and tilt. And again, it's a smart sensor, so it has digital signals going up and down, and you send it 24 volts down to the sensor. This means it includes the transceiver inside of the sensor, which means you don't have a transceiver box on these systems anymore. Just a cable up to the bridge, maybe via a junction box. Now the DL2 was released in about 2015, and it has been worked on a lot in that period. So it has multiple frequencies. So we added that after a few years. It runs at 270 kilohertz as the main frequency, but we also put a second frequency in as about 900 kilohertz, and that is used to measure the speed through water in addition to the low frequency. And this gives it a much higher accuracy than we had in the older systems. So we are managing quite easily to get 1% on the systems as long as the system is calibrated properly. If you combine the DL2 and the DL1, you will get to what we call the DL21. This is actually two independent systems, two electrically isolated systems, but they're both put in the same set of housings. So the sensor is still a 100 millimeter sensor, but inside of there you have the DL2 going at 270 and 900 kilohertz, and the DL1, which goes at 700 kilohertz. And these are going simultaneously and independently of each other. Now, if you put both of these into one, they go into one hull mounting, which is, of course, cost saving. But then they also give you the two values out that you need. The DL1 gives the speed through water, the DL2 gives the speed over ground. And this is approved as two systems in vessels that are over 50,000 tons. The EML224 is a, again, sorry, I've gone the wrong way. Then we have the SAT logs, which are a new addition to the Skipper range. We've cooperated with Kongsberg on the antenna, CTEX, and we have made the front end for it. The SAT log has two GPS receivers, meaning that it will give a heading out. This device can also be used in another mode as a heading device, but as a speed log, it has to be a standalone system. So it uses the heading and it uses the GPS speeds, and that is enough to give you a speed over ground speed log. So you don't need to give it any external information. It's obviously got the GPS in it, but it's also got a gyro SAT log heading device in it. So it gives you everything you need for speed. Now, if we combine that with the DL1, just like we did with the DL2 one, then you get the speed through water through the DL1, and you get the speed over ground through the SAT log. And this will give you a combined system, which again can be used on vessels over 50,000 ton as two independent systems, but with fewer boxes. Finally, we have the Skipper EMS60. This is a combined EML and echo sounder. This is a slightly different family of products by itself, but it's still using very similar technology. It's made generally for a minimum specification vessel. So it has an EML and an echo sounder transducer in one sensor, which is a 60 millimeter sensor. So it goes into the lowest cost valves and tanks. Generally, with EMLs, we prefer to have things mounted in valves if we can, because they have to be cleaned every now and then. Finally, I'll just mention the log repeater. As you've got two systems, it's a case of what repeaters do you need? There isn't many vessel classes that have to have repeaters, but most vessels will have a repeater of some sort somewhere. The multi-repeater is made in this dot matrix form, which is very good for bridge wings because it can be very bright in the sunlight and it can be dimmed right down. So the contrast is good. It can show depth. It can show two depths on the screen at the same time, forward and aft if you want, or it can even show depths from two systems. It can show the speed to water, speed over ground, trip, and the settings can be changed so that you can show pretty much what you want on the screen, showing depth or speed or distance or heading or rotation. All of these different items can be put up on a single display. It can show two informations at once on the screen, and if you've got to have it fixed, that is what you'll get, two informations. But it does have 3 runtime screens, so you can set up to 6 informations on it, and you can make it rotate if you want to through the different informations. So here is the setup of the speed logs. You see, this you can find in the catalogs, which are available on the web. You see, we have my mouse. We have the EMLs on the left-hand side here, the older generation of EMLs, which uses JB60 box. Then we have the slightly newer versions that will go into the multi-box. That's for the DL1. And then we have the SATlog system, the DL21 system, and the D2 system. And they all share the same set of valves and tanks, 100 millimeters for the 100 millimeter and 60 millimeter for the smaller sensors. Although we do also have adapters for all of the smaller sensors to go into the bigger systems as well, if you want, as well as very many retrofit options. So basically, if you have a hole in your ship that needs a retrofit solution, and the hole is bigger than our sensor, then we will make you an adapter to fit in it. It takes a couple of months to do new ones, but if you can give us drawings of the old system, then we will make an adapter for it. So far you see on the left-hand side here, we have for the old Simrad NL, that was a DL1 type system, the old Skipper systems, the adapter for 100 millimeter to 60 millimeter, Sachem, and Navinaut we have some adapters for as well for the small versions. And then for the larger versions, we have Sperry and Atlas Dual Log, and most of the systems that we often see now being replaced to the newer systems. Also for our own, the 540 and the DL850 systems also have adapters for the DL2. So how you install this? Then the first thing is the placement. This happens at the design phase usually. And the important thing is that you place the speed log somewhere where it will always be in the water, preferably where it has a laminar flow. That is, that the water is moving in a constant direction and speed, well, not speed, obviously, that's what you're measuring, but a constant direction over the sensor. And you try and avoid where all the bubbles are. So you see, as you come to the front of the ship, then the bubbles tend to be pushed down around the bulb. So there's not many bubbles at the front of the ship. So that is the ideal place to put the acoustics in there. So the speed log can go in here. The echo sounder can also go in here. We generally try and have 2 meters distance between the different sensors. If they're at different frequencies, they should cut each other out reasonably well, but there is always a pressure wave between them. So try not to have acoustic sensors very close to each other. We have had close to 50 centimeters between, and it has worked fine, but it's very hard to guarantee this kind of thing.
Paul, we have one question.
Yes, okay.
It is the question is it okay with ice protection for DL21 for ice breaking vessels?
We haven't got much choice there. We tried at one period to put an ice plate in front of the DL850, and it was it was difficult. So at the moment we use a normal DL2. The DL2 is flush, and that we have found is the best thing for ice. It shouldn't stick out at all. If it is flush, then the ship itself will take the ice rather than the sensor. But what you can do with these is put 2 rails on the side, just slight protrusions outside of the hull, about 50 centimeters on each side of the sensor, going forward to aft, and these will deflect any ice away from the sensor. We have done this on very many ships, and it seems to be very successful. So we don't see the need for special ice protection other than that. But on ice ships, we always recommend putting it into a valve so that you can replace it if it does get scratched, and if you have to, you can pull it up while you're going through ice. The standards have changed a bit here, so as long as you mount a sensor out of the ice zones, so basically at the bottom of the ship, then it is okay to mount it as it is. Does that answer the question?
Yes, and it was luckily that you answered the same as I wrote.
No, it's not luck, it's the truth. Okay, so moving on, the placement, other placement. You see here an array of some strange ships that we have put sensors into. Generally, we get everything working. The high-speed ships, generally, you have to put the sensor further back because you see that the bow is pretty much, these ships pretty much fly. So you have to find somewhere that is in the water. We had one guy who was very good at finding the sweet spot, if you like, for the echo sounder. And the way he did that, or speed log, and the way he did that was go around inside the hull with a stethoscope and listen while they were sailing and see if he could hear the water banging on the hull. I wouldn't advise that as a way of doing it, but that is basically the principle we're looking for. We're looking for somewhere that is in the water, preferably out of the bubbles. And on fast ships, that could be a bit further back. On other vessels, like this sort of floating rig thing, there is no bow. Generally, you have to move away from any type of azimuth thruster, and that isn't always possible. By nature, an azimuth turns around and can blow in any direction. So you try and get as far away from those as possible and be somewhere where you are in the water. Okay, the skipper graphic systems, the multi-systems, they are all very similar in the way they work, software-wise. So I'm going to show you a couple now so we can see how they are set up. Now, the first things you need to do is when you get to the vessel, you need to check that the sensor is in place and it is flush. Flush means it is flat. There is no welding ridges around so that you will have smooth water, no turbulence. Let me just pull up the demonstrations here. Then I need to.
So while you're doing this, I am making all the participants as presenters, so it should now be possible for all of you to ask questions. So it shouldn't be grayed out the conversation button anymore.
Right, I'm now sharing. Sorry, it seems to be flashing a bit. I don't know if that is happening with you. This is a DL2 system. This is what it will look like when you get on board the ship. Our software is also available as Windows version. So on your laptop, you can also connect to the system, and this we use for our remote systems. So here you see the system. You can go into the configuration. You can go into the setup of the system. And here the first things you will do is check the sensor is in place and flush, as I said. Then you can change the tonnage of the ship and the maximum speed of the ship. This is important because this sets the calibration table. And the calibration table is something that you have to fill out as you were doing the sea test. You will need to enter the sensor position and then set up the communications so that if you want an aft speed, you have to put the heading into the system. We also recommend always having the GPS in the system. So you connect the NMEA, the auxiliary outputs that could go to the drive systems, the alarm, BAM, conning, are obviously things that take the speed. And then we also have the possibility to put a number of displays on the system as well. So you can have an emergency fire bridge with a copy of the screen, a fully working copy of the screen. Then you can use the simulators. If you go into the diagnostics, you can use the simulators to produce speed. The system can be used for a couple of hours in air if it needs to be. It's not too sensitive to that, so that's okay. But you run speeds, you test up your bridge. Then while you're at sea, you will need to run the calibration. And here you can calibrate for the speed, you enter the distance, and then you sail backwards and forwards, just like the other calibrations we've done before. And you also enter the installation angle. Now I will run a course separately on calibration of this because this is one of the main things that you need to do during a sea test. You can also do the installation angle, the angle mounting angle. That is slightly different on the DL2 than it was before. And you can do the you can log data and check afterwards using tools that we have. Finally, service and support. I will bring this back up. So the way we are finding service and support on the speed logs with the graphic interface is that it's quite simple for crew or service people to go in with the PC, connect up using the LAN, and then we can help you with support. You can also use the Skipper service software. And there's also a software called GraphLog. All of these softwares are available on the web and are free. Once you have logged data, you can go into the GraphLog and look at the data. You can use the service software to upgrade, and it's got a number of tools that can be used in it as well. Okay, any more questions about the speed log?
Hello, Paul. I have one question regarding this, the location of the sensors in the large bulk carriers. You know, the shape of this bowl of the bulk carrier is quite different with the container vessel with the torpedo. So where is the optimized location of the sensor in these huge, bigger bulk carriers?
Yes, it's a difficult one. And the best person to answer that really is the ship designer, because they will have run models. We very often don't see the models. So we have to kind of guesstimate where the best place is. And generally our rule is put it in the first sixth of the ship, which can be quite a long distance, usually about first 10 or 15 meters, usually just in front of the thrusters at the bow, if you have thrusters at the bow, of course. If it's difficult to get there because it's tanks and you want a valve, then we sometimes put the system between the thrusters, and that works okay. In that case, you sometimes have to use a double bottom system to actually get it mounted. Have you got any comments on that, Sigurd?
Okay, yeah, because
I'm just writing an answer as well.
Okay, thank you. Yeah.
Okay. Right, moving on then. We'll go on to the echo sounders.
I have a question too.
Yes.
It's regarding the possibility to order the adapters for the hull, for the well-known equipments on the market, the old ones, because we have several requests for refittings, and it's not possible to mix up systems, as you know. So the possibility is to change everything, and the big problems we have is in the hull and mainly in the main panel. So is there the possibility to order an adapter in very short time?
Yeah, if you see at the screen now, you can see the adapters we already have. So the some of the adapters we have. So we have for the SAM Atlas dual log, for example. And for the Sperry sensors, we have adapters for those. And we have those in stock pretty much all the time. So if we have the adapter, you can get it pretty much out of stock. But if we haven't seen it before, and we've seen most of them now, then it will take a little more time to actually make an adapter.
Okay.
Okay.
And it is
moving on
also,
to the echo sound.
Just 1 minute, Paul. It is also important to notice that the smallest speed log sensor we have is 60 millimeter in diameter. So if it is a smaller existing sensor, it is not possible for us to make any adapter for the smaller ones. But if it is bigger than 60 or even bigger than 100, it is possible for us to make an adapter.
Okay. So moving on to echo sounder technologies. I'm a bit aware of the time and we're beginning to start running over time. The echo sounders go a bit quicker than the speed logs because we only have 2 in the latest generation. Just going on the history of it, the original way people did echo soundings was to put a stone on the end of a rope and drop it down and measure the rope. Obviously, you can't do that while you're moving. Later, during the First World War, and that time, they got a bit more advanced and started banging on the hulls and then listening for the echo. Obviously, you can't do that while you're moving either because you won't hear anything. So they moved quickly onto the acoustic systems where you have some kind of loudspeaker, underwater microphone, and you send out a ping and you listen back. And what they quickly found was that the different frequencies, the lower the frequency, the further the sound went, and the higher the frequency, the better definition you got out of the system. So we generally have 50 kilohertz as the low frequency and 200 kilohertz as the high frequency. That's not in the rules, that's just how the market has had it over many years. So we have other transducers as well. We have transducers that are down at 38 kilohertz or 24 kilohertz that go deeper and deeper. And on the ESN 200, we recently tested the 38 kilohertz to well over 1,000 meters and the 24 kilohertz down to as deep as we could get, which was 2,500 meters. That was because that is where the bottom was. We couldn't find any water deeper than that. The other thing that affects a transducer is the diameter of the transducer. The bigger the transducer, the wider the transducer, the thinner the beam. And the thinner the beam, the more accurate depth just underneath the transducer you get. The other thing that can affect how well a system works is the processing techniques. Generally, the industrial echo sounders, like the skipper systems, use a narrow band. That means they send out a ping at one frequency. But there are other types of echo sounders, like the fishery ones, that use a wideband or chirp, and that changes frequency, and that gives you some better accuracy, good for going longer distances. It doesn't help at all in shallow water, but it gives you a bit lower noise. So it is a technology that is slowly creeping into the market as well, particularly in the fishery and in the military type vessels. So the skipper echo sounders, we have the ESN series. It's the new series. We have 2 in the series at the moment, the ESN 100 and the ESN 200. When we have developed this, we've been focusing on reliability. We want to be as reliable as the older generation, but we've wanted to modernize the design. So the displays are smaller. They are standalone displays now. They're 9-inch displays at the moment, and they tend to work by LAN communications, internet. Well, not internet, but yeah, LAN. The other thing we have focused for is automatic functions. We had a lot of disgruntled customers before that they had to twiddle the knob too much on the GDS series. So we right from the start said, okay, this system you don't have to touch. We will put a lot of effort into the automatic functions, auto range, auto gain, auto power, auto everything. And we've done that pretty successfully, but we're still working on that, and we're going to be working on that in the future. The other thing was easy setup. Instead of picking frequency, you pick the part number of the sensor, and that means that we can tune the system to the different types of transducers. So that is part of the setup. We found when we started installing these systems that some systems, that our auto functions work well on our test boats, but then when we put them onto real life situations with different cable lengths, different transducers, we get some slight differences, and that has its main effect in the auto functions that stop working properly. So we've added functions recently that now do dynamic noise adjustment. So it adjusts the system so that it matches your vessel. So part of the setup can be to run this noise adjustment, and it will also do some adjustment as it is running. We've also optimized for shallow measurements. The system is approved down to 2 meters, but our systems, we want to measure well below that. Also the deep measurement, again, it's approved to 200 meters depth, but depending on the transducer you have, you can get right down to 3,000 meters. The ESN 200, we have also focused on the integrated navigation system. So this is a standalone box and a display. You can have multiple displays on the system, but eventually you won't need any displays on it. It will go straight into the INS system. Remote service is another thing. Because we've got LAN in there, you can connect using a laptop or a remote server. And then we put all the options into the ESN 200. So if you have a special vessel which needs synchronizing or muting, or a military vessel or something like that, then the options go into the ESN 200. So the ESN 100 is a single channel, but 2 input system. So you can have 2 transducers, one forward, one aft. They can be either 50 or 200 kilohertz, just those frequencies. It doesn't have very much I/O, but it has the basic of what you need. So it has LAN, NMEA, and an alarm relay, which you need as well for the alarming. It runs off 24 volt DC, and this can be input to the electronic unit, transceiver unit, and that can also power the screen, or the screen can be powered locally. Now, one advantage with this system is that it's got 1 pair communication between the screen and the box. And this means if you're retrofitting it, you can use existing cables, but actually mount this box at the bottom of the ship if you need to. That means that you're not running analog signals all the way to the bridge, but you run them to the transceiver unit, and then it's digital signals up to the bridge. In some cases where you've got problems with noise on a vessel, this can help you. But generally, this box is probably mounted on the bridge, just like it has been before, and connected. The NMEA is connected into the display. The ESN 200 is the more advanced system made to replace the GDS 102. It's 2 channels. And then again, it's narrow band, but it's got more frequencies. It's got up to 8 different frequencies you can run. It's got SD disk on it and a USB, which means you can log for months or years, depending on the size of the disk you put in. And because it has got LAN and it's got its own processor in the electronic unit, then it is can work as a standalone unit like a black box, and it's INS compatible. And then the options, we are still adding options, and as customers come with different needs, we will be adding more options. So at the moment it has sync, it has mute, and we're putting in temperature compensation.
Okay, Paul, we have one question you can answer. Yep. He's asking if the 38 kilohertz transducer is approved.
The 38 kilohertz transducer is actually approved now. It wasn't before on the GDS, but on the ESN 200, it is approved as a to be used as a med transducer. Any more?
Yes, I have a question related to the remote management. You know that Telema has connection to all the ship and can manage the system on board using Marlink connections. We want to know what kind of intervention you can do from remote.
Okay, basically anything to do with software can be done by remote. I mean, we have the skipper service software that can be installed locally onto a PC on the ship, but you go in, we tend to use AnyDesk to do that, or TeamViewer. Then you can do upgrade remote or anything remote. We also have, for all of these later generation softwares, we have a Windows version of the software as well, like I was demonstrating on. That will connect to the system so you can sit remotely and see what is happening on the system. We also sometimes use FTPs to get into the system at the back end and all of those sort of tools. So those are all available to use within the system. But you do have to have a PC in between you and the system. It doesn't go directly onto the system.
So the package is complete. Only the hardware part cannot be affected, obviously.
Yes, that is correct. But we do have included a lot of self-test in it. So by going in and running the self-tests, you can find out which bit of hardware hopefully is failing you if it is a hardware problem.
Good.
I have
hello, Paul. One question.
Okay.
Yep.
Yes.
Sorry. Yeah, regarding if this echo sound, the new echo sound is integrated with INS, is it possible for cross mutings to fully follow up this is a BAM requirement? Cross mute. If the alarm is coming from the echo sound, we can mute from the INS and so.
Yes, yes. It is. All of these systems are following the new standards. So it uses ALF messages preferably. And there you can mute, you can, if you put it into the mode that it is INS, then it won't make any sound on the display. Generally, an echo sounder in the latest standards has to beep when there's an alarm going, a shallow water alarm. And you have to go to the display and press it to stop it. It's one of the few parts on the bridge where you can't run a remote alarm. But if you are in an INS system, then it's different. Then you can run a remote alarm to the system, and that is implemented in this.
Okay, and is this mute is through the NMEA channels or the digital channel?
It is the mute is through the let me think. Yes, it's through NMEA. Also okay. The 450 standard of NMEA. So it follows the normal ALF standards, basically.
Okay, thank you.
Paul, does it also support the ALR ACK as an option, fallback option to prior BAM conformance setups?
Yes, we've kept the old options as well. And the other thing that's changed is the ID numbers for the different systems. That has got the old standard and the new standard going in there as well. So we've tried to keep it compatible backwards. But you have to set an option basically of which version you're going to be running. You can only run one option at a time.
Wonderful, thank you.
Okay, so here you see the echo sounder systems as they spread out. We still have the GDS 102 in this system, but the ESN 200 is taking over the GDS 102 from next year. As you see, we've got 24 kilohertz, 38 kilohertz, 50 kilohertz, and a couple of 200 kilohertz. But we also have a combined transducer now, which is 50 and 200 kilohertz. And both the ESN 100 and ESN 200 can be made to switch frequency automatically based on the depth and signal quality. So you can put this in 5200 fore and 5200 aft, and the system will work out what it needs as it's going along. Obviously, you don't really want both channels to be at the same frequency. So there are some challenges with that, but we're working on the rules to actually make it all work smoothly together. Everything is synchronized, of course, within one system, but if you are installing two systems, we are working on ways of synchronizing the two systems so that you can have two systems running simultaneously. So how to put this into the vessel? The first thing is the position in the planning. Again, we say it's the same rules as we had for the speed logs. In front of the thrusters or any other protrusions, the first sixth of the hull, try to be in a laminar flow and as few bubbles as possible. We want the sensors transducer to be as low as possible on the vessel, and it shouldn't be tilted more than 5 degrees. Otherwise, you're measuring off to the side of the vessel rather than underneath. In the aft, there's always going to be some bubbles there, so you may find that the system doesn't work at low speed. but that depends very much on the design of the vessel. A lot of vessels do manage to use the aft as well. When it comes to installation, the first thing is to obviously install the units and connect the transducers. The cabling should not be any close to any electrical noise. And you need a shielded cable, and it should only be grounded at the transceiver, not at any junction boxes along the way. The cabling to the transducer is carrying analog signals. So there we have the same rules as we had with the GDSs, that we have 1.5 millimeter up to 100 meter and 2.5 millimeter screed cable up to 300 meters. Then you connect the communications and the alarm. Nowadays, we tend to connect the GPS input for clock and for position for diagnostics afterwards. Obviously, it goes to the VDR and the navigation system as well. Then we check the noise levels. If necessary, we've found that you can add a power filter. We find that a lot of ships have quite noisy power on board, and this system is quite sensitive. So we have been improving the filtering on the system recently, but there's also some power filters that can help a situation if you have one. Then, because you're on a new platform, there's an auto noise and auto calibration function, which is basically a press the button. It will find out what the noise level is and what's the optimal signal noise ratio is to say that it's found the bottom. That helps the auto functions. You can run the system for a short time in air. We don't advise days and days, but this system has quite a lot of power in it. But you can run it in air for a short time just to test it's working. But generally, there is also a number of self-test systems in there, including simulators, so you don't actually have to ping out of the system to check that everything is working. During the sea test, you check everything is working, that the noise level is low. I will just do a quick demonstration of that so you can see the screen. Just need to. Here you see the ESN 200. This is running a simulation. At the top of the notes that you're looking at, where you can write your comments, you will see links to these simulators and to this presentation as well, so you can download that. We'll also make a video of this, so that we'll post on the web afterwards, so that you can see that. Here you see the echo sounder. It's got 2 channels, so if I swap the channels, you can see that we can get both. The important factors here: you set up the ES setup, you can set up the ship dimensions, the type of ship it is. There's not too much you need to set up here. You can go into the diagnostics, find out about the system. Here you can see you can run simulators. At the moment, we're running a simulator from a file. You can go into the echo scope, and here you can see the signals. And in here, you see the red line is the dynamically adjusted noise level. So signals above that, it will be interested in. And then there's also options on the softwares here to do the simulation in later software versions. Any questions?
Hi, Paul. Bjorn here.
Hi.
I got some experience with this ice plate and the sensors there, and the new sensor type that you mentioned. This new sensor type, this 50/200,
Yep.
Will that be any chance for getting that one approved for GDS 102? That's question number 1.
Okay, we have considered this, but we haven't, because we're phasing out the GDS 102 next year, we haven't prioritized that at the moment. So at the moment, it's not in the plan. Particularly in these COVID times, it's very difficult to actually plan anything. So we're not too sure what will happen, but we're looking at phasing out the 102 at the first half of next year. So probably not is the answer there.
Yeah, I got around something about 8 till 10 vessels that are looking into maybe replacing the one with the ice plate with this new one?
We have recently had quite a lot of issues with the ice plate system. The ice plate system is not ideal in that the transducer is slightly lifted into the hull. And then if there's air swirling around underneath the vessel, then it slowly works its way in and you have to tap the air out. If you've done that in a valve, then you've got real problems. You have to get down to the valve to air it. But if it's done in a tank, you usually have some kind of airing system on there. What we've done is with the ETS 5200, we have tested that using the pressures that are required in the latest standards for ice protection. And it passed all of that. So you can just put the ETS 5200 in instead of an ice solution. Now, that is a big advantage of the new generation, but unfortunately, we haven't got plans to put it onto the old generation. Sorry.
Yeah, we have to discuss that one, Paul.
Okay.
Yeah, okay. Great. Thanks.
Okay, moving on, we've got one, the service and diagnostics of this system. The new system has a USB and an SD disk. If you put the USB into the system, you can turn it on. It will log all information, including raw data, and that can be sent to Skipper, and we can post-analyze it to find out what the noise issues are on your system. That can either be USB or SD. And the SD will log all of the adjustments made on the screen. It will log all of the data coming in, including the data coming from the outside world as well, so that we can get a good picture of what is happening afterwards. But the most important thing we've found so far with the ESN series is to look at the noise levels, because the power supply coming in can give you noise. And if that noise is high, then it will reduce the range of your system. As you're moving from, say, 300 to 2,000 meters, there's very little difference in the signal strength. If you have a noise, that will quite quickly swamp all of that range. So you need to get the noise down. You can adjust the level so that the system is more sensitive if that's possible. And then the tool we made a few years ago that helps really diagnose if there's a problem with your echo sounder or a problem with your transducer is the ETT 985. This will measure the impedance of your transducer, and if you can put in the type of transducer and it will say if it is within the correct range, or it will look at the echo sounder, look at the output of the echo sounder and the input to the echo sounder and check that there's no noise issues in there as well. So that is available as a tool, and we recommend everybody to have one of those. Okay, all of this information, I'm finishing now, only 20 minutes late, which is quite good for me. The brochures and manuals, CAD files, certificates, the video courses, everything is on the web, including the software and the software support. We don't charge anything for this sort of thing. And you also find that with the remote analysis at the moment, we don't charge anything for help. So we're finding that we are doing a lot of remote analysis at the moment. We're logging into vessels. On some vessels, we've actually sent out little computers that they plug in, and then we can log into those computers. And we're finding this is a very useful tool, and this is probably the future of most service. Obviously, if there's hardware problems and things, you can't do that always remotely, but we are building tools into the system so that we can run analysis from remotely, and then hopefully one day we'll end up that you send a card that the survey agent can turn up with the right card and everything will work. We also try and give you some support for the HAT and SAT procedures if you ask for that, so that you know what tests you need to do. That is it for this. We have some plans for some future courses. We have the DL2 calibration course. We have an advanced course, which is how to get the full 1% maximum potential of the system. And we have, I will be having a meeting about integrated solutions, how we are doing it now and how we are planning to do it in the future. Those will be happening in the next few weeks. If there's any other courses, I'd be very interested to know what you are interested in that we can do on the web. Any questions?
Hi, Paul, can you hear me?
Yes.
Yes, I was wondering, in your first part of the presentation, you told about Doppler logs being able to measure depth as well.
Yes.
I was wondering, do you have any future plans to make these Doppler logs also MED approved for echo sounding?
That is a very difficult one because an echo sounder really needs to be looking underneath the vessel, and the Doppler log is looking out at a slant, so it's very difficult to so we can't get that approved as a depth. So effectively, we are giving some extra values of depth, one looking ahead and one looking to the side. There are talk of combining sensors. So we have the EMS 60, which also includes a fully approved echo sounder, which is looking straight down in addition to the EML. And it has been our dream for a few years to actually get a combined sensor for both echo sounder and speed log. But we would, as these are two separate systems, it would have to be one of these combined systems that we did it with, or two separate electronic units with the same transducer. We are always looking at that, and we do hope to do that in the future, but we're a little bit size limited with that 100mm.
Okay, I understand. Yes, thank you for explaining. But are you also planning to integrate echo sounders and Doppler logs in one sensor, or only electromagnetic with echo sounders?
We would like to. At the moment, we're concentrating on getting the two products totally in place and all of the things around them. And then, yes, that is a next stage that we would like to do, if it's possible. At the moment, our Doppler systems, they are at 270 kilohertz, so that we get the depth of up to 200 meters from the Doppler system. And if we go up in frequency, because we want smaller transducers, then we lose some of the range of the speed over ground factors. So that is always a balance that we need to see. What is more important, the long range of the Doppler system or the combined system?
Okay, thanks for explaining.
I have a question.
Yeah.
We Telemar, we are providing your system since 15 years to our big ships, but strangely we are on your website only as sales. And we do.
Okay.
What is your policy regarding the support service? What is your policy? Because we don't have any agreement with you about this policy. It seems that you allow everybody to service your system, and you don't have any kind of agreement on that.
Okay, we have a few agreements. We have a level of service center called hubs, where they have some stock, and they are like the focused service companies in certain areas. But we do allow anyone that has been on a course to do a service. There is no reason why you as Telemar shouldn't be on there as a service as well. So if you talk to Sigurd afterwards, we can try and arrange that. It's not done through any policy. It's just we tend to put on the website the people that have been on the courses recently.
Okay.
Okay, any other questions?
Hello, Paul. So if for the big vessels, if you have two sensors, one in the bow side and then another one in the aft side, which frequency you recommend for the aft one?
Okay, the generally the aft center might not work when you're sailing at speed. So it's no point having the low frequency that you want to measure deep water with, because that tends to happen while you are sailing at speed. So we normally say put the low frequency sensor, if you need two frequencies, at the bow and the higher frequency at the aft. There's no reason why you can't have two low frequencies forward and aft as well. But there will always be some more turbulence and bubbles at the back of the ship. So there we tend to put the sensor that is less important while you are sailing out in the ocean. So the low frequency at the front and the high frequency at the back. If you use the ETS 5200, you have both options at both ends.
Okay, and do you have any testing figures and below which speed and the aft one can working? For example,
that depends very much on the design of the vessel. We have had vessels where it will work all the way up to 25 knots or whatever, and then we have vessels where it seems to stop at about 6 knots at the worst end. But generally, you will have a depth at up to around 5 knots. That should work for everything. The one thing you do have to be careful of is that after the ship, it's often very flat, and when you are totally stopped or going very slow, you might actually build up some air underneath there, and that can cause a blockage on the transducer. So we've seen a number of ships that at anchor have had air collecting under the ship, and there are some pressure sensors that actually blow air out as a part of their measurement, and if they are too close to your sensor, then you've got a bad mixer. You've got something blowing air in front of the transducer. So be careful that it is sticking out into an area that will always be in the water. So super tankers and things, we have a few problems where the vessel underneath is slightly concave and you get a build-up of air underneath.
Yeah. Okay, and so we know this. The in aft we have too much bubbles. From the air bubbles. Yeah, but do you know or experience is the engine vibration, or it will be also gives influence to the sensor working?
No, not really. I haven't seen anything like that, particularly aft. In the bow where you have thrusters, then you can both have electrical noise from the thruster, and there's also a lot of turbulence coming out of the thrusters, particularly azimuths and things like that. So there, yes, you will get an influence from the thrusters, but not usually due to vibration. I've not heard that we have vibration problems.
Yeah, because the vibration of the engine is sometimes maybe the frequency is very close, to the sensors. Yeah.
Right. Yeah. It's not impossible, but we've never actually been able to prove that a vibration has done anything. I guess that's quite easy to disprove by running your engine at different speeds if you can do that.
Okay.
But obviously, it's not the sort of thing they do just as standard. So you'd have to define what they want to test for that.
Okay, thank you.
Any more questions?
Hi,
yeah.
Paul, can you hear me?
Yes.
Hi, this is Bruce from, I'm in Cape Town. I just have a question about the Doppler speed logs. We have a polar research vessel that sails from Cape Town down to Antarctica once a year, and she's got a DL850 installed.
Okay.
That sensor is installed very close, right at the bow, underneath her 2 bow thrusters. It's also flush, but that sensor, the vessel's 6 years old now. That sensor's been replaced 4 times now. And I thought it was quite interesting that you mentioned these rails around that sensor to protect it from the ice. Is that something that you guys have documented as a standard, or is it just something you've seen engineers do to help?
I mean, Gail would probably have to help on that one, but I think we have documented it, but it's not something that we've kind of insisted on or anything like that. But it's something that we know customers have done for many years. In the olden days, we had the DL850 540 version, which stuck out slightly from the hull. And this was the way that they used to save those, because we had quite a good business of replacing those sensors, because every time the ice came, it got chopped off. That is why we went to a flat sensor in 2007. And since then, we haven't had any sensors back where we have had ice damage on the front. So I would be quite surprised if there is ice damage on it, but certainly rails would help. And if you're in an Antarctic vessel, then yes, there is quite a large chance that ship is going through ice quite a lot, I guess. So it certainly wouldn't hurt to put those on next time you can.
Okay, I'll look into that. Thanks, Paul.
Okay. Okay, well, thank you very much, everybody, for listening. We had over 100 people listening today, so that's a new record for us. I hope you have got something out of this. I'm sorry if I have spoken very quickly and you don't understand me. On the videos and things you play, there is some auto translation systems that might work if you're lucky. We will post this video onto our website so that other people can see it. The people that have been invited will get it on their list and they can download it straight after the meeting. If you want anything else on the course, please send us a mail or put it on to the comments on the side here, and we will send out some more dates and times for the future courses. Thank you very much.
Is it possible to have this presentation?
Yes, that is also available on the web at the moment. If you go into online courses on the web, then you will find this presentation already there. I will put the links in the comments afterwards, so you can go back into this meeting and see those comments afterwards.
Thank you.
Thank you very much.
Thank you.
Thank you very much.
Yeah, thank you, Paul.
Thank you.